So because AE from here is congruent to EC, so therefore 4y plus 2 equal to 7y minus 1. And this side is 4y plus 2. And then we're going to distribute that. So we got 7y minus 7. Now, I'd like to do something in positive. So I'm going to flip this equation. Becomes 7y minus 7 equal to 4y plus 2. So therefore, minus 4y on both sides. We got 3y minus 7 equal 2. Then we add 7 on both sides. So just like we did when we did algebra. So it's 3y, okay, actually 7 equal to 9. Then we divide by 3 on both sides. Then y is 3. So that's how we find the y. Good? Wonderful. So we find the y. Y is 3. Okay, we got that. Y is 3. Now we're going to find the x. Well, because this side is parallel to this side, and if we're going to draw a line parallel to this, so you can see what we have, what happens, and make line like that. Well, which means that we know, first of all, this side, we had the parallelogram. So parallelogram, the opposite sides are congruent. So this side is congruent this side. And we also know that because those two are parallel, so this angle is congruent with that angle. That's the corresponding angles. One is inside, interior, one exterior. So because parallel, so they have to be the same. And also we can see because this is parallel to this, then we know this angle equal to that angle. And because this line is congruent to this line, we got angle side angle. So we know this triangle is congruent to that triangle. So therefore, this is also equal to that, which means that this point is right in the middle. Okay, so this is a theorem we actually learned before. So when you draw the line as a middle point, this line actually is half of this line of the base. So therefore, what we got here is 3x plus 5, which is half of the bottom line, which is 12x minus 8, and that gave us 6x minus 4. Again, I like to play with the positive number, so I'm going to flip it. So 6x minus 4 equal to 3x plus 5, then minus 3x on both sides. We got 3x minus 4, then we got 5, then we got plus 4 on both sides, and 3x equal to 9, and then divide by 3, x equal to 3. Good? Yeah, so that's how we solve for that. Now, the problem 2 is going to help us to set up, we call that system equations, because there are two variables. Therefore, we need to set up two equations. Well, because D is the middle point of AC, so we know this side is congruent to that side. So therefore, 3x minus 2y then equal to 8. That's the first equation. And we're going to set based on this. Now we know this side is half of this, which is the same as this side is twice of D. So 5x minus 3y equals to 7. Okay. Now, there's two ways to solve that. One is called elimination, another called substitution. So I like elimination. So whenever I can, I always do elimination because that makes things a little bit easier. Okay, so what we're going to do, we're trying to cancel them. So we're going to decide which one we want to cancel. Now, if we want to cancel the x, we are going to make this 2 the same. So find the least common multiple. So we're going to times 5 on the top and times 3 on the bottom. So that way we got 15x. So top, we got 15x minus 10y equals to 40. Then we got 15x minus 9y equal to 21. So we're going to so I'm going to use the top minus bottom. So 15x can cancel. Negative 10y minus negative 9y is minus y. And top minus bottom, so we got 19. So then y is negative 19. So we got that. Then we're going to find x. So to find x, we can either plug in, doesn't matter which one to plug in. So normally I just trying to make something easier. I picked one easier. The top one, we know that it's 3x, bottom one, 5x. So I'm going to take the top one. So that means 3x minus 2, negative 19 equal to 8. Then we got 3x plus, make sure we got that correct. We all got negative. Yeah. Okay. So we got 38 equals to 8. Then 3x will be minus 38, give us negative 30. So x is negative 10. Now we got those two, and we have to verify. We call verification. Make sure we got that right. So now we know that top one, 3x minus 2y should be 8. Well, let's see. 3 times negative 10 minus 2 and negative 19. Then we got negative 30 and plus 38, which is 8. So that's good. Now we look at this one. This one should be 14. So 5 times negative 10 minus 3, negative 19. Then we got negative 50 on the top. 19 times 3, 3 times 9, 27. So 57. Ah, something not right. We only got 7. Should be twice of that. So that's how we know something's not right. Okay, let's go back. 3x minus 2y should be equal to 8. Then 5x, that's 3y, should be 14. So I might messed up here. Instead, it's 14, I probably did 7. Okay, we do the same. Times 3 on the top, we got, 5. So we got 15x minus 10y equal to, we did times 5, so it's 40. Bottom, we times 3. So 15x minus 9y equals to 3. 14 times 3, we got 12, so 42. Okay. So therefore, top minus bottom, we got negative y, and 40 minus 42, negative 2. So y is 2. Okay, we got that. Then we plug into here. So 3x minus 2 times 2 gave us 8. Then 3x plus 4 equal to 8. Then make sure 2 to 4. Then 3x is 4. Then x is 4 over 3. Okay. Negative 2. Somewhere is not right. Okay, let me go back, check it. 5x minus 3y, 3y minus 2, 3x minus 2y equal to a. Bottom 14, we times 4. 5 times 8 is 40. And 15x, 10y. That's good. Then we times 3 on the bottom, 15x. And 3 times 3, 9. 3 times 14, it is 42. So now top minus bottom, negative y equal to negative 2. Then y is 2. Oh, okay. I got it. This actually is not plus 4. So that's actually minus 4. So that's why it's good to check. So plus 4 on both sides. We got 3x equal to 12 divided by 3. Then x is 4. Okay. So we got y equal to x equal 4. And then we're going to go back and check it. Okay, 3x minus 2y, so 3 times 4 minus 2 times 2, that's 12 minus 4, which is 8. That's good. We check the first one. On here, 5 times 4 minus 3 times 2 give us 20 minus 6 is 14. Well, twice of 7, 14. So good. So that's how we can make sure we got that right. Good. Okay, now we're going to do the next problem. So this is called a two-column proof. So this actually help us really understand. And we're going to prove, we're going step by step. This is something we call logic thinking. Okay, so if someone's uh, telling us to think logically, that's what they mean. We're going to think through it step by step. Every step is clear. Okay, so we gave a statement on the first column, then we give the reason on the second column. So first of all, we know A is the middle point of OX. OX is from here to here. And we actually is help to looking at the theorems we have learned before. Let me find it. Yeah. Okay, let me put it in different way. Okay, I'm going to put side by side so that way we can see how do we use the theorems we learned to help us do the work. Okay, side by side. And you can see the theorems. Okay, let's go back. So when we try to prove something, basically is we're going to tell them the reason. And a simple way to do that is just give the theorem. Use the theorem to help us. Can I, looking at both, I don't know if do you see both or just see one?
I only see one.
Hmm. Okay. Yeah, it doesn't allow me to see both. Well, uh, now we're just looking at this one and kind of have a review what we learned on the theorems. So the first theorem, 2-6-1, is saying that if two lines are parallel, then the distance from them, from any point, will be the same. So that's uh, theorem 2-6-1 is equal distance. And second one is if three parallel lines divide one transversal into congruent segment, they are dividing any transversal into a congruent segment. So it's like we did on this one. If this side is AB is congruent to CD, then on the other side, XY will equal to YZ. So that's all it means. Three parallel. Cut one um, transversal and cut them into equal length. Then any transversal goes through three line will be cut in equal lengths. And we got theorem 2-6-3 that said a line that passed through the middle point of one side of triangle is parallel to the other side, which we actually used early on um, to find our x and y. And the 4-6-4 is that the segment joining the middle point of two sides of triangle is parallel to the third side and is half the length. So we learned on here uh, that if we have a point, middle point, then we draw a parallel line, then we're going through the other point. So this actually is kind of like the converse. It's saying that if we have we join two middle point and first order, they're going to be parallel. The the line joining the middle point will be parallel to the third side, and also it's half a length, which that's something we used to do that. So basically, that's where it is. Okay, then we're going to use that to prove. Okay, let me actually get that bigger. Use those theorems. Okay, first of all, we know A is the middle point. A is the middle point here. And AB is parallel to XY. And BC is parallel to YZ. And AC is parallel to XZ. Oh, so we're going to prove that AC is parallel to C to XY. So that's going to prove. Well, we know that B will be the middle point. So B is the middle point, the midpoint of uh, OY, and that's our theorem. Theorem 2-6-3, which says that if you had middle point here and draw a line parallel uh, to that, then this will go to the middle point. Okay. And we also know that BC is parallel to YD. So same idea. Then if you can parallel to that, then C is the middle point, midpoint of OC. Okay. So same thing. That's theorem 2-6-3. And then now we know C is the middle point, and this is the middle point. And so therefore, we know AC is parallel to XZ, and that's our theorem theorem 2-6-4. Good. Wonderful. Now we're going to looking for uh 4. I mean, let me trying to push this down. Okay, so that way we can see that clearly. Okay, all right. Okay, it is given that ABCD is parallelogram. A, B, C, D. A, B, C, D is parallelogram. And we know BE, this one, is parallel to MD. So those are parallel. And M is a middle point. So this side is congruent this side. And we're trying to prove DE is equal to BC, trying to prove that. Okay, so how do we do that? And so first of all, we given that this, we know this is the middle point, and this side is congruent, parallel to this side. That means D is a middle point. Midpoint of AE. And that's our theorem. Theorem 2-6-3. So that's mean this is the middle point and this is parallel and it has to get to the middle point. Okay, so therefore AD is congruent to ED. That is the definition of the middle point because we already proved that D is the middle point. And the definition of middle point is that this side is going to congruent that side. Well, we also know that BEC is congruent to AD. AD. Okay, this is congruent to that. And that because it's a parallelogram. So one of the theorems, parallelogram tells us, and we can always go back to the textbook and find where that is. So because they are parallelogram, because ABCD is parallelogram. Now, because BC equal to AD equal to DE, then we know BC is equal to and DE, or DE equal to DC. Yeah, so this is something called transitive property. Transitive property, which means that if A equal to B and B is equal to C, then A must equal to C. So we know that DE is equal to AD and AD is equal to BC. So therefore DE is equal to BC. So that's how I prove this one. Okay, are we good on this one? Yeah, very good. Very good. Okay, let's do number 5. Number 5 said that it's given that PQ and RS and TU are perpendicular with UQ. So PQ, where's PQ? PQ is here, and RS is parallel, TQ is parallel. And R is the middle point of PT. So this side equal to that side. And want us prove that RU, this one, RU is congruent to RQ. Okay, so how do we prove that? Well, first of all, in order to prove that, we are going to prove this triangle and that triangle are congruent. But how do we prove the congruency? Well, first of all, we know this is congruent to this. So US is equal to QS. So that's our theorem. Theorem 2-6-2. We're talking about parallel lines. If we cut on one side, you also cut on the other side. So if this is congruent this, then this has to be congruent that. So that's basically what we have here. And we know also um, uh, RS RS is equal to self, RS. That's called the reflexive property. To anything congruent to itself. Okay, so now we still had to prove we got two sides now. We had to find if we can find the angle, that would help us. Well, so we're going to use the parallelogram, something parallel. Okay, so we know um, because this is parallel to that, and this also we can extend that, can just help us. And so this side, and we got a line like this side. Okay, so we know this is congruent to that. And we know this is congruent to that. And so if we connect them, RU equal to RQ. Okay, so if we extend that, okay. Well, we know this one is congruent to this one, and this one also congruent to this one. And so this one is congruent to this one. And we need to find the R is the middle point of PT. RU is RQ. Okay, let me think about this one. What else? So we had to prove this congruent to that. We know this is congruent to that, and this is congruent to that. And this by itself congruent to that. And so we know this one is congruent to this angle. Who hmm, okay. Yeah. So I have to think about this one, make sure I got that right. Okay. I'll once I got that right, I'll just make a short recording and so you can watch that. Okay?
All right.
Okay. All right.